So another way that Pythagorean theorem questions can be given to you is actually on a grid, so it's actually on a picture. The biggest difference here is that you actually have to draw the triangle. So the distance they're asking me for is this distance between A and B, so if I draw a straight line there, this is going to be my, my hypotenuse, my C value. That's what I'm looking for. Now I need to draw the rest of the triangle as well. So to get the rest of the triangle, what I'm going to do is start at one of the points. So I'm going to start at A, and I'm going to go either straight up and down or straight left and right to get in line with B. So if I start at A, for example, I could go straight to the right, and I could go straight up to get in line with B. Okay, now remember, you have to go along the grid lines. You can't go diagonally. You need to go straight along the grid lines. So if I do that, this distance along the bottom here is actually 8 boxes long. This distance right here is actually 2 boxes long. And then again, I'm looking for this distance right here, which is C, because my right angle is actually right here. So I'm going to do my Pythagorean theorem, a squared plus b squared equals c squared, making sure that c squared is my longest side, which is what I'm looking for. I'm going to substitute my other two values in for a and b. Now it tells me to square these values, so 2 times 2 is 4, 8 times 8 is 64. And then it tells me to add those. Together that would be 68. Now remember, that is c squared. So in order to get just c, I need to take the square root. Now the important thing here is it says the exact distance. That means they don't want me to round, they don't want me to do anything like that. So in this case, I'm actually going to leave it as the square root of 68. So luckily the one on your test like this is multiple choice, so you shouldn't have trouble with that. Now, just to kind of make sure our answer makes sense, the square root of 68 is about like 8.2, which makes sense because it should be bigger than 8 and 2. So it being 8.2 makes about sense. All right. So the other thing that they could ask you to do is to find the perimeter. So if I was asked to find the perimeter of this triangle DEF, okay, I would count any side lengths that I could. So for example, the side length between D and E, so I can actually count that. This distance is 12 boxes long. Now the problem is the other two sides from D to F and then F to E, I can't count those because they don't go along the boxes. They go like through the boxes. So I'm going to have to actually treat it just like I did the first problem here. So let's say I'm looking for DF. I'm going to have to draw a right triangle that goes from D to F, where that's my hypotenuse, that this value is C. So to get from D to F, I'm going to go straight down until I get in line with F, and I'm going to go straight over. All right. So if I actually count this, D going down here is actually 10 boxes long. This side length right here is 6 boxes long. And again, I'm looking for this side length right here, which is C. So I'm going to substitute these into my Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to do A as 6, B as 10, and C is what I'm looking for. Well, 6 squared is 36, 10 squared is 100, and if I add those together, I'm going to get 136. Now remember, that is c squared, so I need to take the square root of that to get just c. So when I take the square root of that, I'm going to get about 11.6, which is equal to c. Now the thing is, it tells me to approximate to the nearest unit. So 11.6, is it closer to 11 or closer to 12? It's actually closer to 12, so I'm going to use 12 for my c value. All right, now that's the distance between D and F. I got to do the same thing between F and E, but what you'll notice is when I actually draw that triangle again, is that the side lengths are actually the same size. It still has a bottom length right here of 6 and the side length here of 10, so that if I solve it using the exact same Pythagorean theorem, I'm going to get that this length is also about 12. So then if I'm looking for the perimeter just means to add up your side lengths. So to go from D to E to F and back would be 12 plus 12 plus 12. Now it's just coincidence that they all happen to be the same side length. They don't have to be. Okay, so again, they don't have to be, they just happen to be in this case. So if I add all of those together, I'm going to get 36. So please, please, please don't forget that you're not just looking for this distance between like D and F or F and E, you're looking for the perimeter. So you need to add all 3 side lengths together, and that you can count this one between D and E because it goes along the boxes as opposed to D and F and E, which go through the boxes.